If you tried to factor, which is usually the first guess that you're going to need to use the quadratic formula, you'd have tan theta and tan theta. There's no choice there. This would have to be 7 and 1 to give me 7. And I hope you see that no matter what you try for the outside and the inside, you're never going to make 3 with 7 and 1. So obviously, this doesn't factor. If something doesn't factor, the only way we could solve a quadratic equation is to use the quadratic formula. So this formula in the green box is on your formula sheet, and it says for ax squared plus bx plus c. But we don't have x squared. We have tan squared. So instead of x equals, we're going to write tan theta equals negative 3 plus or minus square root of 3 squared minus 4 times a times c, all divided by 2 times a. And simplifying this, nine plus 28 is 37 over 2. Is that on your pie plate? No. And the plus or minus actually means there is 2, you can separate them. You have 1 with the plus, so I can write that one out, negative 3 plus the square root of 37 over 2, and 1 with the minus, that would be tan theta is negative 3 minus the square root of 37 over 2. And we can go to our calculator, and sometimes it's helpful. This would be a calculator question, obviously, because you have to find your reference angle. And sometimes it is very helpful to change these to a decimal. So I'm going to write these out. I'm going to write out the positive one first. Negative 3 plus the square root of 37 divided by 2 is 1.541. So I could write tan of theta 1.541. And I notice that that's positive. So that tells me it's in quadrants 1 and quadrant 3. I can find my reference angle by, again, going to my calculator and going tan inverse of, and I can either go up and highlight this one or highlight all those decimals. If I do tan inverse of this, I get a reference angle of 0.995. Sometimes in my notes, I just put ... to remind myself I haven't rounded early. Sometimes if you go to 3 decimal places early, it can make your final answer off a little bit, in which case you're going to lose a rounding mark. So we'll keep our decimal places for as long as possible. Sometimes that's helpful to, above the on button is a store button. Sometimes it's helpful to hit that store button and store that reference angle as x so you can use it later. Okay? In this case, since tan is positive, you would get an answer in quadrant 1, which would be 0.995, and you would also get an answer in quadrant 3. So in quadrant 3, I'd have to go to pi plus my reference angle, which I stored as x, and I get 4.137. On this side, if I type that one into my calculator, so negative 3 minus the square root of 37, all divided by 2. Oops. I have to put it. Oh yeah, I just want to find out, first of all, it's negative. So I just wanted to type that into my calculator. To find out that it's a negative value, because now tan will be in quadrants 2 and quadrants 4. Again, I'm going to find my reference angle, tan inverse of positive value. So if I select one of these, it's going to be negative, right? Couple things you can do. If you select something and it's negative, you can make it positive by multiplying it by a negative again. Or I could have used the back key and deleted that negative. But remember that whenever we do a reference angle, we always do the inverse of a positive value. So I find out that my reference angle is 1.354. Again, I'm going to store this as x. And since tan is negative, now I'm looking in quadrant 2, which would be pi minus my reference angle, 1.788. And I'd be looking in quadrant 4. For quadrant 4, we'd have to go all the way around the circle, 2 pi, and then minus our reference angle, 4.929. You'll find it very typical when you're solving. You'll get into a rhythm where, put an arrow to both of these, we just solved once around the circle, from 0 to 2 pi. Once you've done that part, because you kind of get into a rhythm, and by a rhythm I mean you're like, I know how to solve trig equations. I have to find my reference angle, use my cast rule, list my angles. There's a lot of work that you have to do. And so because there's a lot of work that you have to do, you sort of get into a rhythm, and then you get done. And this is a prime place to make an example because you're like, I'm done. I'm going to move on. This is where, at this moment, we have to take the time to look back and read the question again. Did the domain say between 0 and 2 pi? What kind of domain was given? Okay? And this one, does it say between 0 and 2 pi? No, it doesn't say anything. So if no... It means everything. If they don't tell you, right? You can't say like, x plus 1 equals 5. And you're like, everybody's like, x is 4. Well, or I could say, no solution because I only solved between 0 and 1 and there was no answers between 0 and 1. No, you can't restrict the domain if it's not given. If no domain is given, they're expecting you to find all of the answers. Okay? Although typically on the final exam and on tests and quizzes, it was considered not as clear to students. So they will always say, either they will say this part where they tell you theta is all the numbers, or they will say give the general solution, which also means all numbers. So a reminder from yesterday's class. If we have the general solution, or all real numbers, what were our steps? Our steps were solve like normal between 0 and 2 pi, right? I don't know if we call this one normal because we had to use a quadratic equation. It was a little bit new that way. But we still did the steps like normal, found our reference angle, used our reference angle to solve between 0 and 2 pi. So we did step 1, and then step 2 is to each answer, all we have to do is list every single thing that's coterminal with every answer we found. So by adding the 2k pi, we'll have solved this completely. So I go down here, and now my final solution, I'll write like this. Theta is equal to, put a big squiggle bracket like this, and I'll list all 4 of them. 0.995, doesn't matter the order, so I'm just going to list them. Some people like to do them so that they go from smallest to biggest. And then we go to each one of them and say, I'll write all the coterminal angles for every single one. And if I introduce the letter K, I have to describe where that came from, and so K is an integer, positive or negative whole number. And this would be the final answer. Did I already get you to circle questions 5, 6, and 9? Question?
Because it's 10, could you also just do the pi
Yes,
thing?
yes. So you could have, so that's a good point. Because it's 10, these two, I'll circle them. You could have chosen one of them. This only works with 10, by the way. And I think it's just easy, probably for your brain, just easy to be like, okay, I found all my angles, just add 2k pi to them. But you could have combined those two that way, and also combined these two that way, and had a somewhat more elegant looking answer, okay? But for our purposes, we're going to find, by finding our answers first between 0 and 2 pi, then you don't even have to worry, is it tan, is it sine, is it cosine? I'm just going to add 2k pi to each of those answers to get every single coterminal one. That's going to work all the time. And the exam is not going to be like, oh, we're looking for the most elegant form. You didn't provide that, so we're taking off a half mark. That part they're not concerned, which is kind of nice.